in question 5D.1, you're asked to find the exact values for sine theta and cos theta given the information tan theta is equal 2/3 and the domain is limited to theta is in the first or the second quad. Oh, it's in the first quadrant because it's pi on 2. So if we just use the restricted domain between 0 and pi on 2, that means that tan theta has to be in quadrant 1. Or that theta. So we know two things. We know that tan theta by definition is sine theta on cos theta. And we're told that tan theta equals to 2/3. Almost the only time you're allowed to do a running equals is when you've got two common things. And we want to write that in terms of one of the trig functions. Sine theta equals 2 cos theta on 3. And we also know the identity theorem, cos squared theta plus sine squared theta equals 1. So we can substitute this equation for sine theta into equation 2. And so instead of sine theta, we're going to write 2 cos theta on 3. So this cos squared theta stays there, plus. Now, sine squared theta actually means sine theta squared. So we're going to put 2/3 cos theta. And just to emphasise, it's all of it squared. And it equals 1. So 2/3 squared is 4/9. And then cos theta squared we're going to write as cos squared theta. So we've got 9ths. So 1 cos squared theta is 9/9 if you like. So 9 plus 4 is 13/9 cos squared theta equals 1. So cos squared theta equals 9/13. And cos theta square root of 9 on square root of 13 is 3√13. Now we also have to find sine theta, and we know that cos squared theta plus sine theta equals 1. And looking back here, we know that cos squared theta is 9/13. So sine squared theta must be the rest, 4/13. So sine squared theta so that's from using the identity theorem. So sine theta is the square root of top numerator and denominator. Square root of 4 is 2 on root 13. And so we're done. And it asks for the answer exactly, so leave it in the third form.